Welcome to you all in our another lecture of CSE437. In this lecture, we will discuss about the inferential statistics part 2. So in our previous lecture, we have started discussion on inferential statistics and we want to continue the discussion. So in our last class, we have discussed about the hypothesis testing process. And in this class, we will discuss more hypothesis testing methods. Let's say one problem is given here, okay? Like blood glucose level for obese patients have a mean of 100 with a standard deviation of 15. So blood glucose level of obese patients, the mean here it is given like 100 and standard deviation is 15. So this is the global thought, or you can say the common thought or common observations, okay? That this mean is 100. So we can see that there is a mean, that is mu is 100. And we have also, it is given that there is a standard deviation, or you can say sigma, the standard deviation, it is given 15. Okay, 15. Now a researcher thinks that a diet high in raw corn stress will have a positive or negative effect. Positive or negative effect on blood glucose levels. So that means a diet high in raw corn stress will have positive or negative effect. It means that if any patient consumes just maybe raw corn stress, then their that is glucose level, it will be more than 100 or maybe less than 100. So that's it is mean that it means that is it has the positive or maybe negative effect on blood glucose levels. Now this is just a thought, okay, just a hypothesis or thought, but we need to prove it. That is whether the idea or thought of that researcher is correct or maybe not. And for that reason, that researcher collected the sample of 30 patients who have tried the raw corn stress and have a mean glucose level of 140. So this researcher collected the data from 30 patients, and those patients have just raw corn stress diet, and that researcher measured the glucose level of that one of the 30 patients and found that the glucose level is 140. Okay, here is the 140. So now, based on this observation, we have to test the hypothesis whether this one is accepted or rejected. In our previous lecture, we have discussed about hypothesis, specifically two types. One is called null hypothesis and another one is called alternate hypothesis. So null hypothesis is a common belief and alternate hypothesis is what we want to prove, or the alternate thought of the researcher. So here in this case, at first what we have to do, we have to state the null hypothesis. The null hypothesis in this case, it is that there is the mean glucose level of patients, okay, of obese patients is 100. So that means in our hypothesis, we have to write the null hypothesis is mu, that is mean, equal 100. So this one is our null hypothesis. Now we have to write the alternate hypothesis. The alternate hypothesis, that means we can see that from our observation, what we think that there is the raw corn stress will have a positive or maybe negative effect. Okay, so that means the mean value, it can be increased or maybe decreased. In other way, we can say that that is the mean, will not be 100. Or we can say another way also, that is that it can be less than or maybe greater than 100. That is not equal, okay? That is not equal. So here we have defined the alternate hypothesis. This is our alternate hypothesis. So we have defined the null hypothesis and we have defined the alternate hypothesis. Now we have to test it. For testing, we have to select the alpha level, okay? The alpha level. State the alpha level. Then first the alpha level. Alpha level is our that is significance level. So it means uh, here we assume that alpha is 0.05. So alpha is 0.05. So this is our threshold, 0.05. 0.05. That means 5%. Alpha is 5%. It means that we can just maybe uh, assume that we can uh, we can consider maybe 5% of error. If we think about the alpha level, what is that? So it is a significance level, and the threshold of the significance level we consider, that is 0.05, that is 5%. So 5% of error. Then what is the significance of this? So it means if we maybe run a test, like if we just maybe consider about our machine learning model, the accuracy of that, then for the case of our machine learning models, if we run the first time, then maybe you will get the error rate is 92%. Sorry, not the error, the accuracy. Accuracy is 92% accuracy. But if we run second time, then maybe you will get like 95%. If we run maybe third time, then we will get maybe 85%. And then sometimes maybe 99%. So that means in several iteration or several run, maybe the accuracy level is varied. Then if we consider, that is we will define the significance level. That means if we just repeat the statement again and again, then maybe we will get the accuracy level. We can define like 92%. 92%. This is considered just like an average, okay? Average, you got the 92%. But you have also mentioned that is sometimes you got like 99%, sometimes you got 85%. But 95% of the time, 95% of the time, you will get the result. 95% of the time, you will get the result within maybe we can consider within 90% to 90% to 95%. So 95% of the time, you will get the result within this upper and lower limit. So here the lower limit is 90 and upper limit is 95. So 95% of the time, you will get the same or the result within this interval. So that is called the 95%. That means in this case, you allow some percentage of error, that is called 0.05%. Okay, 0.05%.
Sir, I had a question actually.
Yes, please.
Can I ask, sir? So, we are saying alpha is the error significance percent, right? So alpha is always 5%. We consider because it's standard, right? Now my question is, sir, what which value are we comparing this to? Like 5% error যে আমরা মার্জিনটা ধরছি, এটা কোন ভ্যালুর সাথে কম্প্যারিজনটা হচ্ছে, এটা কি মানে আমার প্রাইমারি নাল হাইপোথেসিসের মিনের সাথে, আর আমাদের যেটা মিন বের করবো সেটার সাথে? আমি একটু কনফিউজ এটা নিয়ে।
So it will be considered our there is the statistical mean. That means whatever you got from the sample.
Okay, sir. So that means my 5% should come within 140. So আমার যদি হচ্ছে 140 কাছাকাছি থাকে, like 139 আসে, we will
That's
still
why
consider it as our hypothesis being proven or disproven, এরকম কিছু?
no, not like that. Okay, that's why we have some approaches like uh, that is the G test, T test, and some other testing method. Okay, I am discussing about that. Okay, so that means that the error directly, if we can say that okay, this one 140 and average is this, so it is increased. So that's not like the hypothesis testing approach. Okay, so it is a little bit different. So I am discussing about that. Okay, so it is not directly like my error is 140. So that means it just we can say uh, add +5 and maybe subtract -5, then we will get the range. No, you understand my point?
Yes, sir. So we can see how it works in the
Yeah.
math, I guess. Yeah.
Okay. So that is here we can assume that okay, our alpha is 0.05 and it has the significance. Okay, that means if the error is more than that, then those will not be the significant. Okay, so that's why this is a standard. Or we can say we can consider also the alpha is 0.01, that is the below 0.05, but we cannot exceed this. Okay, we cannot increase the alpha level. So those will be insignificant test on that case. So this is one of the standard like 0.05. So now here is the state the alpha level. So we have stated the alpha. Then next thing is find the rejection area from the G table. We have to find the rejection zone. Rejection zone. So if we consider about the rejection zone, then at first we need to think about that our data is normally distributed. In our previous lecture, I have already mentioned why we need to consider the distribution. Okay. So here we assume that data is normally distributed. And if we assume that, then only we can apply some form of hypothesis testing like the G test and T test. If not, then we have to consider some other tests. Okay. We will discuss about that also. That is when to use which test. So now the task is we have to find out the rejection area from G table. Okay, from G table. But before that, we have to think about like the G table has two forms. One is for one-tailed G table and another is for two-tailed G table. So whether we need the one-tailed or we need the two-tailed. And for that, we have to look to our alternate hypothesis. The alternate hypothesis, it is the meaning here is mu not equal 100. Okay, not equal 100. It means it can be greater than or it can be less than. So if we consider our normal distribution curve, that is in our previous class I have already mentioned. So this is our normal distribution. Okay, usually bell-shaped curve. This is normal distribution, and we know that the normal distribution is symmetric. That means 50% data we get in left side and 50% data we will get in right side. So that's why the 50% we will get in this side and 50% we will get this side. Now, this 50%, we have to consider about our error also, okay? About our error. So we consider that alpha is just 5%. That means we have, if we consider 100%, that is 1 minus of 0.05. So 0.05. So it is 0.95, okay? 0.95. So that means 95%, 95% significance level we can consider. That means within the 95%, 95% data. So if we consider 95, but This 95 can be, that means in both of the side. Okay. So that means this portion and this portion. Okay. Both left side and right side. If we combine, then it will be 95%. So what we can do, as the data is symmetric, we can divide this one by 2. So if we divide this one by 2, then we will get what? We will get 0.475. 475. Okay, 0.475. So here is 0.475. That means 47.5% data we will consider in left side, and 47.5% data we will consider in right side. Those are our valid region. Okay, that means if we get the data within those region, that's valid. But now we have to find out the rejection zone, that is rejection zone from the G table. And for that, we will use this value, that is 0.475, this value, 0.475. So again, the G table, as we already considered, that G table must be two-tailed. That means in less than and greater than. So this is the greater than side, and this is the less than side. Okay, that means less than the mean, greater than the mean. So here is our mean value. This is our mean value. This side will be greater than, and this side will be less than. So that means this is a two-tailed test. Therefore, we have to use the G table of two-tailed. That is two-tailed G table. Okay, what is that? Two-tailed test. So this is a benchmark. This is a benchmark and benchmark table. Then we have to find out our value. That is, in our case, it is 0.475. So where is 0.475? We can see here 438, 475. 475 is here in this case. This is 475, 0.475. And this is 0.475. We will get the G score or G value. For that, it is 1.9 here, 1.9 plus of, then in column we will get 0.06, so 0.06. That is our 1.96. Okay, so we got 1.96. That means this value 0.475, it will be within 1.96 standard deviation. Okay, 1.96 standard deviations. So that's why we can consider here our this is the point. Okay, that is 47.5%, and G score will be 1.96 for that case. Okay, 1.96. So this is actually 1.96 standard deviation from the mean. And similarly, we have to think about our negative side also. This is left side also. Left side, it will be negative 1.96 standard deviation. Okay, so we have already identified the that is the rejection area. That means these are the acceptance zone. So these are the acceptance zone, and outside of this zone, or we can say larger the standard deviation of 9.6 and negative 9.6, lower than that will be our rejection zone. So this is our critical point, and beyond the critical point is our rejection zone. So this side is our rejection zone. This side is our rejection. Similarly, in negative side, we also have this side is our rejection zone. Okay, so we have identified the rejection area. Next, we have to find out the test statistics. That means from our survey, whatever we get, then we have to find out our G score. Now we have to find out our G score. And for that, the equation is this is the equation of our G score, x bar minus of mu 0 divided by sigma divided by square root of n, where x bar, this one is our, that is the sample mean. So here the sample mean is our 140, okay? So this is 140. So this is our x bar. X bar is 140. And then mu 0, this is the population mean. That means whatever uh, that is existing mean. So this is our existing population mean. Population mean is mu equal 100, okay? So mu equal 100. So here is the mu equal 100. Then sigma. We already know the sigma is 15. So here we can use the sigma. And then the n is the number of instances or number of samples. We have considered here 30 patients. We have collected the data from the 30 patients. Okay, so here is the n is 30. So if we do the math, then we will get 14.6. This 14.6 is a standard deviation from our data. Okay, from our data we got the standard deviation, that is 14.6. So 14.6 actually it will be far uh, more than the 1.96. Okay, so this one is far from our 1.96, far from our 1.96. So that means this value is in rejection zone. This value is in rejection zone. So what does it mean? It means that we have to reject the null hypothesis. We have to reject the null hypothesis. So if we reject the null hypothesis, then that means we have to accept the alternate hypothesis. An alternate hypothesis is this: that is, a researcher thinks that a diet high in raw cornstarch will have a positive or negative effect on blood glucose level. So that means the researcher idea or researcher thought or researcher hypothesis is true. So this is how we have to test the hypothesis using our that is G test. Okay, if you have any question.
Sir, I think you are presenting the wrong screen.
Wrong screen.
I cannot see any slides. Now I can see, sir.
You can see now.
Yes, sir.
How about other students?
Yes, sir, we can see.
Okay. Okay, then now we want to discuss another example of hypothesis testing. Here, a principal at a certain school claims that the student in his school are above average intelligence. So this is the claim of a principal regarding his or her students. Okay, that is, he just claimed that his or her students are that is more intelligence than other. That is why he claimed that above the average intelligence. Okay. Now we want to test this claim, that is whether the principal's claim is true or maybe false. And for that, a random sample of 30 students, IQ score have a mean score of 112. So we that principal just randomly select 30 students and also maybe test their IQ score. And the mean IQ score received by that sample, from that sample, it is 112. Okay. Is there sufficient evidence to support the principal's claim? The mean population IQ score is 100 and the standard deviation is 15. So these are given. Okay. Mean, the population mean is given here is again the 100 and the standard deviation is given 15. So we need to test whether the principal's hypothesis is true or maybe false. And we have collected the data for that purpose. Now we want to apply again the G test. So what we have to do at first, we need to we need to formulate our null hypothesis. And in this case also the null hypothesis, there is our H0. H0 is 100, mu equal 100. Then we have to think about our alternate hypothesis, that is H1, where mu equal. Now we have to think about like above average intelligence. Above average intelligence means
Greater than, sir.
yeah, the
Yes, sir.
greater than the
Null hypothesis.
so that means we have to write like greater than 100. Okay, greater than 100. That is greater than 100. Okay. So this is our null hypothesis, and we have already defined our alternate hypothesis also. Now, estimate the alpha level. As an standard, we can set the alpha equal 0.5. Okay, 0.05. Okay, 0.05. So this is the significance level we said, that is alpha equals 0.05. And then find the rejection area from the G table. Now, if we want to find out the rejection area, what we have to do, we have to consider our, that is acceptance region. So here 1 minus 0.05, that is, it will be our 0.95, okay, 0.95. 0.95. Using this value, we have to find the G score, or you can say the standardization value from our G table. This time we can see there is whether we need to use the that is two-tail test or one-tail test, and we can see it is greater than. So that means it is one-tail test. Okay, one-tail test, and that is in left side or right side. This one is in left side or right side?
Sir, it's on the right side.
On right side, yes. So that means we can say this is 95%. So here is our right side. Okay, so right side. We have to apply one-tail test here. And for that, we have to use the G table of one-tail test. G table. Okay. So we can see this one G table left, and this is our G table right. Okay. So that means we have to use this one. Now for that we have to find out the value is 0.95. Okay, that is 0.95. We have to find out this value. So now we can see 0.95. Here is a 9293, 951, 9594, 95, and 9505. Okay, that means the value must be within this range. Within this range, that is the 95. We have 0.95. 0.95. Okay, 0.95. So 0.95 will be within this upper and lower bound. Within this upper and lower bound. But we didn't find the exact value. Okay, we didn't find the exact value. That's why maybe we need to estimate the Z score for that. Okay, the Z score for that. Then how can we estimate that? So we can see if we try to find out the difference between our value and difference in our standard deviations. So at first, difference between the value. The difference between the value in this case, it is 0.9505 minus of 0.94, then 95. So if we subtract, then here is the 0, and then 1, then 0 and 0 and point. Okay, so this is the difference between those values. And then difference between the standard deviations, here it is 0.05, and here is 0.04. The difference in standard deviations is 0.05. Here is a 1, then 0 point. Okay, so that means 0.01. Now, if we consider our value, we have to check that is 0.95. How much difference it from our lower bound? Okay, so lower bound is this one. The difference in this case, we can see our value is 0.95 and the lower bound is 0.9495. So it means here it is 5 and then 0 and then 0 and again 0. Okay, so that means this value and this value, the difference is 0.0005. Okay, now for this there is this difference. For this difference it's 0.0010. That means for point 0.0010, for this difference in value, the standard deviation difference is 0.01. 0.01. So for the difference 1, the linear relationship we can write like 0.01 divided by 0.0010. So this will be the difference. If the difference of value is 1, then standard deviation difference will be 0.01 divided by 0.0010. Now, if the difference is this, because from this value, our value is this one, the difference is this. Then for this much difference, for 0.00 and 0.5, for this much difference, the standard value difference will be this one, that is 0.01 by 0.0010 times 0.0005. Okay, so this much difference. So we can write it it is 0.01 times 0.0005 equal this divided by 0.0010. So it means the difference is 0.005. Okay, so that means for this much difference, the standard deviation difference will be this much. Okay, that means we can see now if we want to find out the total standard deviation here, it is 1.6. So 1.6 plus of, then we can see this is lower bound is this one, 0.04, then plus of, our value is not 0.9495 but 95. So here for the 95 the difference will be 0.005 plus 0.005. So it means we will get 1.6, then 4, then 5. So this will be the standard deviation for that case. Though we have calculated linearly, actual value is actually non-linear, but this one is the estimation. Okay, just estimation. So 1.645. Now we can use that one. So here the T table, the rejection area, rejection zone, we can see here 1.645. Okay, so this is the point or critical score or G score. So 1.645. That means within this standard deviations, all these are just acceptable. And the rejection zone is this, okay, this 5%. This 5%, that is alpha 5%. This 5% is rejection zone. But we have to now that is the find out our test statistics. Okay, so our value, our G value. So it is our average of our sample data. So average of our sample data, it is average is 112. Okay, so 112. It will be 112, 112, and minus of then mu 0. We can see in that case the IQ score, that is population IQ score, population mean is 100. Then we have to divide it by sigma. Sigma is what? Sigma is 15. Sigma is 15. Okay, 15 divided by square root of n. N is what? N is the number of participants, and we can see here number of samples. It is 30. So here is 30. So if we do the math, then it will be 12 divided by 15 times the square root of 30. So maybe if we do the math, then we will get so 30 and a square root of that times 12 divided by 15. It is 4.38. Okay, so we will get 4.38. So this is our statistics. This is our statistics. Okay, so that means this is the standard deviation, and we can see that actually this value is larger than this one. Okay, so that means our value, our G score, it will fall in the rejection, maybe this area. So this is 1.645 standard deviation from the mean, but our statistics falls in 4.38. Okay, 4.38 standard deviation from the mean. So that is also far from our 1.645. So if it is in rejection region, then we have to reject the null hypothesis. That means here is also we have to reject the null hypothesis and accept our alternate hypothesis. So alternate hypothesis is the claim of our principal that his or her students are more intelligent than others. Okay, so that is the true fact for that case, for that school. Okay, so this is another hypothesis testing. Now I think we have to study a little more. That is when we have to apply which test. So we have two similar tests, that is T or G test, but it will depend on that is the two things. At first, you need to think about that is whether the sample size is small or maybe the large or standard. And the sample size is small, then the population variance and the population variance is known. On that case, you have to apply t-test. And when the sample size is large and the population variance is known, then we have to apply g-test. Okay, so sample size is large. Usually, we assume that sample size 3 and greater than 3 are the large sample size, and less than 30 is our small sample size. Okay, and population variance is known. Okay, population variance is known. Population variance is sigma, the value of sigma. So if we know the sigma, and also there is sample size is large, like greater than or equal 30, then we have to use z-test. And we can see in this case the 30 students here, and 30 students also 30, yeah, 30 students here, and 30 patients here. It means sample size is large, we can consider. Okay, and also the sigma is given. There is a standard deviation sigma is given here. Okay, so G-test and T-test, based on the sample size and based on the given population variance, we can select whether we have to apply G-test or T-test. We have to know a little bit more. A T-test and G-test can be one sample T-test and maybe two sample T-test also. The one sample T-test, the equation is this. Similar to our G-test, the equation is here. Okay. X bar minus mu 0 divided by S divided by square root of n, where x bar is the sample mean, S is the sample standard deviation, n is the sample size, and mu is the population mean. For two test samples, that means we have to take the samples 2 times. Okay, that is called two sample t-test. So on that case, for the case, the first sample and then second sample. Okay, the x1 bar minus of x2 bar square root of s1 square divided by n1 and s2 square divided by n2. Here x1 bar, this one is the sample mean of first group, and then this x2 bar is the sample mean of second group, and s1 is the standard deviation of the first group, and s2 is the standard deviation of second group. N1 is the number of samples in first group, N2 is number of samples in our second group. Okay, so that's the two sample t-test, one sample t-test and two sample t-test. When we have to reject the null hypothesis, and that is, if we compare our test statistics, that is called statistics. If the statistics is greater than the table value, okay, greater than the table value, table value, or you can say t score. Okay, so table value table, then we have to reject the null hypothesis. In both of these cases, that is both of these tests, we got that. That is our value. Here, this is our test statistic. This statistics is greater than our G score, 1.96. That's why we have rejected the null hypothesis. And here is also the same. Our statistics is 4.56, which is greater than our 1.645. So we have rejected the null hypothesis. Okay. And G-test can also be two types, one sample G-test or two sample G-test, using the same formula. Okay, yeah, the same formula, like the two sample T-test and two sample G-test. Now, what will be the standard number of samples? That means called sample size. So we have to have there is enough number of samples, or that is the significant number of samples also, to define the statistics. Okay, and that's why how can we calculate that? There are several equations for that, and one of the equations proposed by the Awasana in 2013 in his research, that is in his research paper, and there is this is called the sample size determination equation. And in this case, the sample size, it will be depend on several parameters. The first is the p here. Okay, that is the p value. P value. And then the p value is also the significance value. Actually, p and alpha is very, very close. Okay, the p value and alpha, that is uh, so the alpha is the threshold and p the obtained value. Usually we call it p. Obtained significance is p and threshold is alpha. uh, so you will find that is the p, it is less than or equal 0.5. Okay, or you will define that is p uh, less than or equal maybe 0.1. So this is p value and this is called a standard. Okay, the standard alpha. Here is the alpha. This is alpha. Okay. Uh, so p value define that, okay, maybe 0.5 if we consider this one as the p value. Then we have to think about also the error. There is plus minus something, that is our error. So error is 0.05. You can consider any kind of error. Okay. Like maybe the acceptable error range is 0. Maybe 3 or 0.03, like whatever you can consider based on your how precise you want to test your statistics. Okay, so this is error. And then g represents the value, that is our g score or a standard deviation score. For the case of our 95% confidence level, we have previously already studied that it is 1.96, like here. Here is this. Okay, for our 95% confidence level, okay, it is 1.96. So if we apply this value in this equation, that is P, G, and E in this equation, then you will get 385. So it means that at least you have to collect the data from 385 participants for testing or for claiming your significance or claiming your hypothesis, that is it is true or maybe false. Okay, this is the number of participants and determination. There are some other equations also.
Sir, I have one question. So
Yes.
you're saying we should have a good, a proper amount of sample size distribution, right?
Yeah.
But if my question is already given, so why do we need this?
Question?
I mean, কোশ্চেনে তো আমাদের স্যাম্পল সাইজ দিয়েই দিচ্ছে যে 30 জন এত করেছে, এটা এত
No, no,
করেছে, সো আমাদের
this is another issue. This is for your research. Okay,
ওকে
you want to prove your hypothesis. Okay, that's why you have to collect the number of that is you have to survey people. Maybe you want to determine that is how many people we need to survey.
ওকে স্যার, গট ইট স্যার, থ্যাংক ইউ।
If the course in this course and its sample is given, then there is no point. Okay, it is sample is given 30 students, so that means you have to use this 30. But this is for the research. Okay, you have to determine or you have to collect the how many patient sample for the statistical significance. So for your population, considering your error and considering your standard score, it will be calculated. Like you have to collect the data from 385 participants if you want to test the significance of your data. Is it fine? Any question from your side? If not, then I think we want to
স্যার
discuss.
আমাদের ফাইনালটা কি এক্সাম হবে না অ্যাসাইনমেন্ট বেসড?
আমরা পরে ডিসকাস করি এটা ক্লাস শেষে।
ওকে স্যার।
Okay, the next thing is, okay, I want to continue hypothesis testing part, more details. So hypothesis, as you know, last class we have discussed that hypothesis, it can be a null, it can be alternate hypothesis. And only null hypothesis is nullifiable. So we can test only the null hypothesis always. So the null hypothesis, so hypothesis testing, and we can say what we have to do. We have to collect some data for statistical purpose for testing our hypothesis. And hypothesis testing actually divide into two types. One is called parametric test and another one is called non-parametric test. Okay, the parametric test, the G test, T test, and F test, and ANUVA, those are called the parametric test. And that is chi-square test, U test, and ACE test, those are called the non-parametric test. Okay. Uh, then why it is parametric and why it is non-parametric? The parametric tests are applied under the circumstance where the population is normally distributed or assumed to be normally distributed. That means if you fit your data and if you find the distribution of your data, and if the distribution of your data is normally distributed, then the parametric test will provide you the accurate result. Or sometimes you need to assume, though maybe those are not fully normally distributed, you need to assume that those are normally distributed. The next thing is parametric. The mean parametric, it means that we use the mean standard deviation, okay, in our parametric test. So as I already mentioned, and we have tested two parametric tests using the G test, so using the mean and standard deviation. Okay, so that means that those parameters we need to have for parametric test. And for example, these are the parametric tests, and these are applied where the data is quantitative. Okay, quantitative. So quantitative, that means you have the quantitative data, and that's why you can calculate the mean and standard deviation. Okay, so you have the numbers, not like that is the excellent or good, some qualitative measurements. You have some quantitative value. Okay, and these are applied when the scale of measurement either be interval or maybe ratio scale. Okay, something that's the interval value or maybe ratio value in your data. Then we can apply. For the non-parametric test, the thing at first we need to think about, like the population is not normally distributed. You can find out the skewed distribution for that. Maybe left side is skewed or maybe right side is skewed. In our last class, we have discussed the skewed distribution also. Okay, so or we can say that we have to assume that the data is not normally distributed. So for the non-parametric test, the second thing is where you cannot apply the parametric test, you have to think about non-parametric test. Therefore, this non-parametric test is also called the distribution-free test. Okay, that means uh, uh, maybe you cannot fit your data in any distribution, in beta distribution or maybe some other distributions also. So parameters like mean standard deviation are not used in this case. And some of the example of non-parametric tests like chi-square test, many unit test or U test, and Kruskal-Wills test or ACE test, okay, and Spearman's rank correlation test, those are non-parametric tests. And usually it is applied when data is qualitative. That means some ranking is given, or maybe some linguistic variables are given, like excellent, good, very good. So those are some qualitative values. These are applied when a scale of measurement is either ordinal or maybe nominal scale. So ordinal is first, second, third, like this way. Okay, so excellent is first. Maybe outstanding is first, excellent is second, like this. Okay, ordinal. So those are the non-parametric tests. So you can see the non-parametric test we have already applied, Z test and T test. Sorry, those are parametric tests, and we have also the non-parametric test. Now we want to discuss one of the non-parametric tests. That the popular one is chi-square. Okay, so chi-square test. I think we have already discussed about the null and alternate hypothesis, so no need to discuss about that. So before going to discuss about the chi-square test, at first we need to we need to know a little bit more about some of the terminologies in statistical testing. And one is called confidence interval. So confidence interval, it is how much uncertainty there is with any particular statistics. So that means if you have any particular statistics, as I already mentioned, there is some uncertainty. That means you just run your machine learning model, and 92% of the time, you got maybe 92% accuracy. Sometimes you will got 95% accuracy. Sometimes you will got 99% of accuracy. Sometimes maybe you got 81, sometimes like maybe 87% accuracy. Okay, so that means different run you will get different types of accuracy. Then you will say that the score, that is the accuracy score of my model is just maybe 95% or maybe 92%, 92%, say 92%. But this is actually kind of the average. Okay, so that's why what we have to do, we have to think about like the some interval. Okay, there is more than that and less than that. Okay, so 92, sometimes you got maybe 95, and sometimes you got maybe 87. Okay, so you can say that my interval is 87 to 95. So that's our confidence interval here. Okay, and then but uh, to set this interval, what we have to do, we have to consider also that is sometimes you got like 81%, sometimes you got like 99%. So for that you have to say that this interval, we receive the result within this interval maybe 95% of the time. Okay, 95% of the time. So this is your significance level. uh, but maybe that 1% or 2% of the time you will get 81% or maybe 99%. Okay, so if we just define our confidence interval, then we have to say our significance level also. That means the 95% time or something. So in another way we can also say that is, it tells you that how confident you can be that the result from the poll or survey or maybe machine learning models reflect what you would expect to find if it were possible to survey the entire population. Okay. Uh, so like here, confidence level and confidence interval. Confidence levels are expressed as a percentage. For example, 95% confidence level. It means that if you repeat the experiment or survey over and over again, 95% of the time you will get within this interval. Okay. Then confidence, another example here is US Census Bureau routinely use the confidence level of 90% and confidence level of 90%. Then what will be the confidence interval for that case? So on that survey of number of on the survey, the number of people in poverty in 1995 stated that confidence level of 90% of statistics, and the number of people in poverty in United States, it is this to this. So that means this is our confidence interval. Confidence interval within this confidence. That means 90% of the time, if they survey to the people, and then the poverty, the number of people in poverty, they will find within this range. Okay, within this range. So that is our confidence interval of 90% confidence. Um, so here it is stated like this. Then how to determine the confidence interval? The equation for that is this one or this one. And again, we can see we can use the T or maybe G score for that. So when to use T score and when to use the G score? The chart is here. Okay. Uh, do you know the population standard deviation? At first, the question is this: that is whether you know the sigma or not. So if no, then use the T score. If yes, then you have to test another thing. That is the sample size, whether the sample size is above 30 or not. That is the sample size is large or not. Okay. Then we can see if yes, then you have to use the G score. If no, then use the T score. So that is here in confidence interval determination, we have to check two things. At first is sigma, that is whether the sigma is given or not. That is standard population standard deviation is given or not. Then if no, then just directly T score, and if yes, then we have to check this number of samples. If it is above 30, then okay, G score, or otherwise T score. Like in this case, the example, a group of 10 foot surgery patients, that is 10 is our sample size, had a mean weight of 240 pound. Okay, 240 pound. This is the weight. There is mean weight. Then That is our x bar. Okay, x bar, that is mean weight. X bar. The sample standard deviation was 25 pounds. Okay, the sample standard deviation, it was 25 pounds. That means sigma is given. The sigma is given. Find the confidence interval for the sample of the true mean weight of all foot surgery patients, and we need to find the confidence level like maybe 95%. So now what we have to do, we have to apply this formula or that formula. According to this definition, we can see there is sigma is given. So that means we have to go in this direction. But now we can see the sample size is just 10. So 10 is not above. So that means we have to use the t-test. Okay, we have to use the t-score. Okay, t-score. So that means we have to use this equation for that. And at first, what we have to do for the t-score, we have to subtract 1 from the sample size to find out the degree of freedom. Okay, to find out the degree of freedom. The degree of freedom in this case is 10 minus 1. Degree of freedom. Here, degree of freedom, actually, what does it mean? It means that we have a mean value like this one. Then if we know just only the nine people's there is weight, then we can calculate we can calculate the 10 people weight, and we can calculate also the mean. Okay, so we have this mean, and we if we know this 9 people's weight, then we can find out the other people's weight also. So that means our degree of freedom here is 9. Okay, degree of freedom is 9. So 10 minus 1 is 9. Now the second step, subtract the confidence level from the and divide by 2. So in this case, we have confidence level is 95% confidence level. So 1 minus of 95. So this one, we have to divide it by 2. That is 0.25. Why we are dividing by 2? Because we can see there is the confidence interval. It will be in both sides. Okay, positive and negative. So that is upper bound and lower bound we need to calculate, and that's why if we consider as we consider that our data is normally distributed, so on that case we will get 50% this in left side and 50% on right side. So we will get the lower bound in left side and upper bound in right side. Okay, so that's why we have to divide it by 2. Okay, and if we divide, then alpha will be 0.25. Alpha will be 0.25. Okay, the next is we have to find out the t value, that is this t score using this degree of freedom and alpha. And for that we need to look in our t table. The t table is here, and we can see our degree of freedom is 9. So here's the 9, and then our alpha value, that is G alpha, is 0.25, and the value is 2.262. Okay, so here is 2.262. Okay, t value we have determined from our table. Now we have to find out the standard error. The standard error, that means this part is called the standard error. S divided by square root of n. So S divided by square root of n. S is what? S is our sample. Okay, sorry. S is our standard deviation. So standard deviation in this case, it is given 25 pound. So S is 25. This S is 25. 25 by number of samples. Number of samples in this case, we can 10 foot surgery patients. So that means 10. So we will get the error AC, a standard error, and then we have to multiply this standard error by t score. So t score is 2.262. So here is 2.262 times error. Then we will get 17 point something. Okay. Then what we have to do, from the mean we have to subtract to get the lower bound, and we have to add to get the upper bound. Okay, so here is this one is our 240 is our mean. So it is the mean value is 240. Then we have to subtract the 17.88 to get the lower bound. Here the lower bound will be this, and upper bound will be 240 plus of that. Okay, so upper bound is this. So this is our confidence interval. The confidence interval is 222.117 to 257 and 0.883. So this is how we can determine the confidence interval. Now we can think about our chi-square test. Chi-square test, as I already mentioned that it is actually one kind of non-parametric test. Okay, so in case of non-parametric test, that means if we want to if you want to apply some qualitative data, or maybe you can say there is mean is not needed or not defined, the standard deviation is not given. So on that case, you can think about our chi-square test. Like here, we want to test a hypothesis that the zodiac signs are evenly distributed across the visual artist. Okay, zodiac signs are evenly distributed. So like we can define our hypothesis 0. The zodiac signs are evenly distributed across the visual artist. So this is a common belief. Okay, we assume that okay, zodiac signs are the visual artist also have the same portion of zodiac signs. So that is our common belief. And now someone mentioned that okay, zodiac signs are not evenly distributed across the artist, or the Aquarius and Capricorn are more likely across the visual artist. Okay, so that means the zodiac signs are not evenly distributed across the visual artist. So that is our alternate hypothesis. So the common belief is for the visual artist also the zodiac signs are evenly distributed, but some people can think that okay, maybe most of the virtual artists, that is visual artists, are from Aquarius and Capricorn group. Okay, Capricorn group. So that's the zodiac signs are not evenly distributed across the visual artists. For that, to prove this hypothesis is true or not, we have to collect the data. And for that, we have collected the data from the 256 visual artists. Then how do we define the 256? Okay, that means how can we get that is 256 from 256 if we collect the visual, that is the data from 256 visual artists, that will be enough for testing our hypothesis. So how can we know that? Actually, we have to apply some form of equation to find out the sample size. Okay, so we have maybe used that equation and find the sample size is 256. Then on that survey, there is 256 visual artists. We found that the 29 are Aries, and 24 are Taurus, and 22 are Gemini, and 19 is Cancer, and 21 is Leo. In this way, we have got that is the different zodiac signs, the people within our visual artist. Then what we have to do, we can maybe apply now the chi-square test for testing our hypothesis. The chi-square test, the equation is this. This is the equation of chi-square test. Okay, so this is called chi-square. This is our symbol. This symbol is called chi. Okay, so the chi-square. So now it is what is it? Here is we can see this is our observation, and this is our expectation. There is number of observed instance minus expected number of instances, and then we have to subtract and square of that. Then we have to divide by E, that is expectation. After that, we have to sum up all values. Okay, then we will get the chi-square values. Okay, chi-square values. Like in this test, we have Aries, Taurus, Gemini, Cancer, Leo, Virgo, and the observed instances are this. That is for the Aries, it is 29. Here is the 29. Taurus is 24. Here is the 24. And Gemini is 22. Here is the 22. In this way, all the zodiac signs observed people, we can write it here. And then now we have to find out the expectation. Okay, expected number of people in each and every group. Expected number, it is 256 we have collected. So the expected number of people is divided by the number of zodiac signs. Here areas torus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have to divide it by 12. And you will get 21.33. Okay, 21.33. So this is the expected number of people in each group. So this is expected. Now we have to find out observation minus expected. So 29 minus of 21, it is 7.66. Similarly, 24 minus 21 is 2.667. 22 minus 21.33, you will get 0.667. Okay, so in this way, we will get the residual. That is observation minus expected. And then we have to square that value. Okay, square that value. Square that value. Then we will get these values. Now we have to divide it by expectation. So we have to divide the 58.78 divided by expectation is what? 21.33. Then we will get 2.775. Similarly, the 7.11 divided by 21.33, you will get 0.334. Okay, so in this way we can calculate the component, that is y minus ei whole square divided by ei. And then what we have to do, we have to apply the summation. Okay, we have to apply the summation. That means we have to add all these values. If we add all these values, then we will get 5.094017,203. Okay, this is the value of chi-square. Okay, this is the value of chi-square. So chi-square we got, the chi-square value we got, that is our 5.094. Now what we have to do, we have to check the chi-square table. Okay, for our that is the critical value, for our critical value. And this is chi-square table. To apply the chi-square table, we need the degree of freedom. So here is degree of freedom. Degree of freedom is that is how many we have? Total 12. So 12 minus 1, that is 11. Okay, so here is degree of freedom is 11 we have. And if we want to find out this value, this is 5.094. So 5.094 will be within this duration, 5.094. Then we can see that within this duration, there is a critical value or p value. It will be 0.95. Here is the 0.95. That means p value will be, we will get the p within this range, like it will be greater than 0.9 and less than 0.95. So we will get the value, p value within this range. Okay, within this range. And we can see there is the p value here within this range, whether the p is significant or not. Previously, I have mentioned that the p is significant. The significant value of p, it will be greater than, actually, less than or equal 0.05. That is called significant, and other than not significant. Okay, so here, if p is greater than 0.1, it is not significant. If p is greater than less than 0.10, it is marginally significant. If p is less than 0.05, it is significant, and p is less than 0.01, it is highly significant. Okay, so we can see that our p value will belongs to this range. Okay, 0.9 to 0.95. That means this is not significant. Okay, this is not significant. So if this is not significant, then alternate hypothesis should be rejected. That means null hypothesis should not be rejected because this is not significant. So null hypothesis should not be rejected. In another way, if someone mentioned that, okay, alpha value is this, alpha, if we mention that alpha is 0.05, if it is mentioned, if alpha is mentioned, then we have to check the alpha. Okay, check 0.05. So here is the 0.05, yeah, and 11. Okay, TF 11 and 0.05. So this is the alpha. That's alpha, and on that case, the value we can see the table value is 19.6 675, 19.675. The table value is 19.675. So table is 19.675. And first, our statistics. The statistics is 5.094. So this is our stat. So if the stat greater than the table, then that is we have to accept. Okay, we have to accept uh, the null hypothesis. Otherwise, we have to reject that. So in this case, we can see that is this value is less than. Okay, this value is less than. So the null hypothesis should not be rejected. Okay, null hypothesis should not be rejected. Okay, so that's why we have to reject our null hypothesis in this case. It means that we can say null hypothesis should not be rejected. That means the null hypothesis we have to accept. The zodiac signs are evenly distributed across visuality. This is true. Okay, this is true fact. Now we want to discuss a little more about our that is the chi-square test, because we have worked on just one-dimensional data. So another problem is a null hypothesis. There is no relation between marital status and educational qualification. Someone can mention that, okay, actually there is a relation between marital status and educational qualification. So null hypothesis, we assume that actually there is no relation between marital status and educational qualification. These two variables, marital status and educational qualification, they have no relationship. This one is common belief. But an alternate hypothesis, someone can mention that, okay, actually there is a relationship between marital status and educational qualification. Then what we have to do, we have to collect the data. And here we have collected the data from 300, total 300 students of different groups, of different classes. Like for middle, we have collected data from middle school, then high school, then bachelor, then master, and the PhD. And from the high school, we got never married people like this, and married people 12, divorced is 6, and widowed is 3, and total is 39. We have collected data from middle school, 39 people. And then for high school, we have collected the data from 90 people, and out of the 90, we have never married like 36, and married 36, and 9, and 9. For the bachelor's case, out of that 84 people, we have we found that never married 21, and then married 45, and then 9 and 9. Okay, and for the master, these are the values. Okay, we have collected the data from different groups of students of different schools and maybe universities to prove our hypothesis. Now, what we have to do, the next thing is we have to apply the chi-square test here, the chi-square. And then to find out the chi-square, we know that what we need. We need the original observation or observation minus of expected value. Okay, expected value. Then we have to find out this expected value here. The expected number of observation for middle school never married. So that means this area. So the expectation is the probability times the frequency. Okay, so probability in this case we can see that is our 90 out of the 90 here never married people, and 300. So that means 90 by 300 times the 39. Okay, 39. So 90 divided by 30, that is the probability, and then we can see the frequency to total middle school is 39. So here this is the expectation. Okay, the expected value for never married is this. Similarly, if we want to find out the expected value for high school never married pupil, it will be that is from the 390 to 90 by 300. So 90 by 300 times this 90. Okay, this 90, then we will get 27. In this way we can calculate the expected value. Okay, so expected value we will get expected, these are the expected value. Then if we consider these expected values, and then we can apply our that is equation is our uh, that is the chi-square. It is summation of that is observation minus of expectation and then a square divided by expectation. Okay, so this equation. So if we do the math, our in this case our observation is what? This is observation and this is our expectation. So 18 minus 11.7 and then a square. Okay, then divide by the expectation, that is 11.7. Similarly, this is our original value and this is the expectation. So we have to add all these cases. Okay, so if you add all these cases, then you will get this is the chi-square calculated. This means this is our statistics. Okay, this is our statistics, and we can see here is a 23.57. So you will get from this data, if we apply here, then you will get 23.75. Now if we consider about our significance level is 0.05, we have to find out that is the tabular value of our chi. So tabular value for that, again we have to check our table. Where is that? This one. Okay, on that case we can see 0.50. Okay, 0.50, and we have the degree. Okay, so we have to compute the degree of freedom. Now what will be the degree of freedom in our case? We need to determine the chi-square tabular value, we need the alpha and also we need the df, that is degree of freedom. So in this case, degree of freedom, it will be, that is the row minus 1 times column minus 1. Okay, so row minus 1 in this case 1 2 3 4, that is 4 minus 1 is 3, 1 2 3 4 5, 5 minus 1 is 4, 4 times 3 is 12. Okay, so I think here 12. Okay, degree of freedom 12. So we have to check it in our table. Where is that? Here. For the 12 and then 0.5 alpha, the value is 21.026, that is 21.03, 21.03, and here is this, we can see 21.03. And now we can see that statistics, that means our chi-square statistics, it is greater than the tabular value. So that means we reject the null hypothesis and accept the alternate hypothesis. Okay, so here is alternate hypothesis. That means we have to accept the alternate hypothesis. It means there is a significance relation between marital status and educational qualification. So this alternate hypothesis is accepted. Okay. So I think that's all in our today's lecture. Okay, so this is up to this slide will be our syllabus. Okay, will be our syllabus in our maybe final assessment. So any question from your side?
Sir, I had a question. So, basically, we saw two types of tests: E-square test and T test, right? and we saw the uses of them as well. We saw proper sample distribution.
Yeah.
So my question is like for I guess assignments one in my section as well. I'm from section two, sir. So
Yeah. Yeah.
I couldn't join yesterday's class unfortunately. So my question is, sir, for the assignment tests, do we have to do something with the sample distribution as well as chi-square test and t-test, and if we do, how to differentiate between chi-square test or t-test? Will it be mentioned in the question, or will we have some form of hints in the question that will allow us to guide us to what we have to do?
Yeah, that's why in our lectures, already I have mentioned that is when to use which test. Okay, I think here. The parametric and non-parametric. So at first, you have to think about like the whether mean is given, standard deviation is given, and whether the data is normally distributed or not. Then think about these tests. And if not, then you have to think about the non-parametric tests. The first thing is this. The next thing is whether we have to use the t-test or g-test if you want to use the parametric test. And I have also already discussed when to use t-test and when to use the g-test. Maybe here or yeah, the t-test and g-test. So that just the data set will be given, and based on the data set, you have to select that is which test you need to perform. Understand?
Yes, sir. Yes,
Okay.
sir.
So any other question?
Sir, I had an assignment related question. So, we do we have? I mean, how much time will we have, and from where? When will it start, sir?
Assignment related question, it means which kind of assignment?
Sir, the one we're taking instead of the final, the assessment one.
Okay. That means I mentioned that it will be a take home exam.
A take home exam. Yes, sir.
Yeah, take home exam. It means on the exam day,
Mhm. Yes,
uh,
sir.
you will get the question paper from our Google Classroom.
Okay, sir.
And uh, you have to submit your answer script also in Google Classroom. And you will get 24-hour times for that.
Okay, sir.
Okay.
Sure, sir. Thank you so much, sir. Sir, another thing, sir. I'm a bit confused about the mark distribution. So, sir, from the lab assignments that we're doing in data camp, we are getting 30 marks. From quiz, we're getting 10 marks, right, sir? And
10 or we have a scale maybe. We have discussed already. Okay, let me check.
Sir, what's the exam date?
Exam date maybe 5th. It's already mentioned. Okay, 5th October maybe.
Yes, sir.
So it is data science. Why is this here slides? No. I think we have discussed many times these things. So assessment methods, class attendance performance is 10%, quiz is 25%, and final exam is 35%, data game assignment is 30%.
Okay, sir. Sorry, sir. I wasn't
Okay, no
in
problem.
the class last time, so.
স্যার
Yes, please.
স্যার ডেটা ক্যাম্পের আছে যে অ্যাসাইনমেন্টটা স্যার এটার কি ডেডলাইনটা একটু বাড়ানো যাবে?
ডেডলাইন কবে আজকে?
স্যার কালকে
আগামীকাল,
দুপুর
স্যার।
12টায় স্যার। অ্যাকচুয়ালি ফাইনাল উইক তো স্যার অনেক প্রেশার হয়ে যাচ্ছে আর ডেটা ক্যাম্পটা একটু বড় সো
একটু একবার এক্সটেন্ড করা হয়েছে। ওকে, আমরা ওয়ান ডে হয়তো এক্সটেন্ড করতে পারি, একদিন।
ওকে থ্যাংক ইউ স্যার।
ওকে, okay, I'll extend the submission deadline just by one day.
Thank you so much, sir.
Okay. So if you have any other question,
No.
মানে বুঝি নেই কেন ডিউরেশন? না 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 না, কারণ এখানে কোশ্চেন তো তোমার হচ্ছে মানে কারো পরীক্ষা তার পরের দিন থাকতে পারে, আগের দিন থাকতে পারে, কিভাবে পড়াবো?
স্যার টেকওয়ে এক্সামটা যে হবে ওটা কি কপিতে লিখে দেন হচ্ছে স্ক্যান করে আমাদেরকে জমা দিতে হবে?
হ্যাঁ, তোমার হ্যান্ড রিটেন অ্যান্সার স্ক্রিপ্ট আর কি।
ওকে ওকে স্যার।
Okay, then I will extend the deadline. Thanks all of you for joining here. Maybe I need to take the attendance now.
Sir, কুইজটা তো n-1, right, sir? মানে বেস্ট
Best
ওয়ান
one,
কাউন্ট করা
হ্যাঁ,
হয়।
best one, হ্যাঁ। Serial number 1, attendance please. 2, 3, 4, 5,
Present, sir.
6,
Present, sir.
7, 8,
Present, sir.
9, 10, 11, 12, 13, 14, 15, 16, 17,
Present, sir.
18,
Present, sir.
19,
Yes, sir.
20,
Present, sir.
21,
Yes, sir.
22, 23, 24, 25, 26, 27, 28,
Present, sir.
29, 30,
Present, sir. Present, sir.
31, 32,
Present, sir.
33, 34,
Yes, sir.
35,
Present, sir.
36,
Present, sir.
37, 38,
So 36 present.
37 present.
38, 39,
Present, sir.
40,
Present, sir.
41, 42, 43.
স্যার সেকশন 2 থেকে স্যার
স্যার 18 কে একটু দেখবেন স্যার।
হ্যাঁ,
স্যার 18 স্যার সেকশন 1 এর স্যার 18 আর্থিক বন্ধ
হ্যাঁ 18 দেওয়া হয়েছে তো।
স্যার
ওকে ধন্যবাদ।
স্যার 17 নাম্বার সেকশন 2 স্যার
সেকশন 2,
আরিয়ান
7.
রোহান স্যার জি স্যার
Sir, 14 number. Suraya bint Akbar.
সুরাইয়া বিনতে আকবর 14.
This.
হ্যাঁ,
স্যার আমারটা
Section 2.
স্যার আমার হচ্ছে একটা মিসিং ছিল মেবি আমি এই জন্য
So section 2 at 42 number, sir.
42.
Sorry, 41, sir. 41. Nice cover.
Okay.
Sir, section 1 মেশকাতুল আরফিন।
স্যার সেকশন 2 লিঙ্কন ধর
Section 2. ওকে, লিংকন। হ্যাঁ, ঠিক আছে। ওকে।
Sir, section
1.
Sir, 24341070.
2434.
Sir, উপরে আছে মনে হয়। Sir, উপরে 1 serial 1.
এটা?
Serial 1, sir. জি।
Okay, thank you. Okay, thanks all of you for joining this session.
Thank you, sir. Sir, about the quiz related issue, can I email you, sir? For
Yeah,
quiz
why
1.
not?
Okay, thank you, sir. Thank you so much. Assalamu alaikum, sir. Take care, sir. Allah Hafiz, sir.
Sir. Assalamualaikum, sir.
Alaikum salam. Alaikum salam.
আসসালামু আলাইকুম স্যার।
Alaikum salam.